your homework too, but give it a shot. See what you can think of it. I put it as the first one because it's good reasoning. And I'm going to work on getting some other things set up. So I'm going to mute myself while you guys stare at that problem, see if you can get an answer. It shouldn't be too hard. Number 9 from yesterday. Yeah, I gotta look up what it is. Give me a second to do that. Is that from yesterday? So this is... So for number 9, Catherine, you're going from 60 to 48. So keep in mind you start at 60, so this here will be your old value, and 48 will be your new value. And I'm getting that from the context, from 60 to 48. Start there and there. And remember our little formula for this is your new value minus your old value divided by your old value. And you want to multiply that by 100 to get it as a percent. So we're just going to plug in. Our new value is 48. Our old value is 60. And we divide by 60. And this is going to give you a negative number here, so this should be a decrease. And if we're going from 60 to 48, it should be a decrease. So that makes sense. So we can do 48 minus 60. You probably don't need a calculator, but I'm getting tired today. So this is going to be equaling 12 over 60, and this is going to be negative. So we did get that negative number there. And then we're just going to make that a decimal, so divide it out. And you get negative 0.2. And then we got to remember to multiply it by 100. So we're going to multiply by 100, and it's going to equal 20%, and it's negative. So you can have negative 20% as your answer, or you can say it's a decrease of 20%. Number 2 is done the same way, only it's going to be an increase one. So you should be getting a positive answer. Your math test is probably going to be next week. Just because I want to get markup and discount on it. Percent change. You're right, Catherine. It is. I'll do it again. Let me do number 2 first. I already started. But it's done the same way, Catherine. Just plug and chug. T66. Here, again, new versus old. New is 66 minus 50, all divided by 50. 66 minus 50 gives you 16 over 50. And that equals 0.32. Multiply that by 100, and you get 32%. So, Catherine, if this was actually number 9, this would be done the same way, only you're starting at 180 and you're ending at 54. So again, this is your old, this is your new. Same thing, your old number goes first, so 180 minus your new number, I'm sorry, your new number goes first. 54 minus 180 all over 180. So just plug it into this. Once this is in, you can solve it. So 54 minus 180 gives you a negative number, which makes sense. 126, but it's negative. Divide that out, and you're getting that multiplied by 100, and you get 70%. And again, that's negative, so you have a decrease of 70% here. And here you have an increase of 32%. So you're looking at this. Any other questions about yesterday's work? Okay. For those of you following along in the notes, we are on slide 15, which is about markup. And I asked you to look at this first, so if you had a chance to sit there and reason through this a bit, not really too difficult. I just wanted you to look at it and see what kind of information you could get. 16, is that from yesterday? I can give you that. Sorry, Anna's asking about 16. You have an old value, you have a new value. Out of that whole word problem, hopefully you're getting that the old value was 460,960, and your new value is 680. Set it up. New minus old. You'll see that this is an increase. You'll see that this is almost doubling, so we should be getting close to 100 here. But that's just putting it. Subtract your numerators. I'm getting 345,720 divided by 460, 960. Divide it out. 345,720. Equals 0.75. Multiply that by 100, and you get an increase of 75%. And yeah, there will be homework. In fact, this is number 1 on the homework. It's attached. It's not in the book. Your book doesn't cover this stuff. This is just stuff you need to know, because it's actually useful in life. So I asked you to try this one out, and this one you should be able to solve just by sitting there and reasoning and thinking for a minute. So if a painting is on sale for 50% off, and the sales price is $320, what was the original price? So again, thinking about that, just how things work is that you have your original price, right? And you're going to subtract 50% of it, 50% of the original price, and that's going to equal your new sales price, which is $320. So you should be thinking along those lines anyways. We don't know what our original price is, but we can figure out 50% by what we did the other day. That means multiplication there, Eli. But using this percent of 50%, that's half. So you should know this is half the original price. So you should be able to reason through that. If I just add another 50% to that, I get the original price. So if I just multiply it by 2 or add another one, right? 3 plus 3 is 6, 4, 20, so it's $640. So that would be for number one. I just wanted you to see that for reasoning purposes. The problems you're going to get are going to be slightly different from that. Are we finding the part? For here, we're finding the whole. This would be a find the whole type thing. Right? You have a 50% over 100 equals, your part would be your 320, and you want to know what the total was. I don't know if that'll work that way or not. 320 0 divided by 50 is going to get you 640. Yeah, that'll work. So you could set it up that way. Here. 2 zeros equals 50x. You still get the same 640. So I mean, this was kind of what we were doing, but I want you to start thinking about sales prices and things like that. So just keep that in the back of your head. I did not get water. For what we're going to do today, but that was number one. And we're going to talk about markup and discount now, the best we can. So let's talk about markup first. Markup. So what is markup? Markup is, let's say a store buys something and they buy it from your wholesales person, the company, whatever. I don't know. Walmart has to get goods from somewhere, so they buy it from a store that sells, like a wholesale store. Did 320 minus 50. Got it. Oh, okay. We can look at it a different way. Let's look at it a different way then. Let me get that problem back up here. This is not a markup problem. So. We have an original price. I'm going to call that X. So original price is called X. So what we're doing here is our original price, so X minus 50% of x. And again, this is multiplication, is going to equal 320. So this is actually going to say x minus, again, we can't use the percent here. So I'm going to make it a fraction. Well, I'll make it a decimal. 0.5 times the price. And remember, of is multiplication equals 320. You really haven't done this algebraically yet, but we can do it. Probably what we want to do is distribute that negative sign, maybe. I don't know if that's what you like or not. Well, actually, that just gets rid of the parenthesis. In this case, we have x minus 1.5x, which they're like terms. You can actually do that. If you recall that there's a 1 in front of this, so 1 minus 0.5x equals 0.5x, 320, and then I can divide by 0.5, divide by 0.5, and that should give it to you. 320 divided by 0.5 gives me that 640. This will cancel, leave you x, and this does give you the 640. This is not percent change. Percent change was yesterday. This is more of finding the whole. This is a finding the whole problem. It's dollars. We're going to do problems that are similar to this. We're not going to do problems exactly like this. Because 1x minus 0.5x is 0.5x. The problem with that is that this is 0.5, so that's half of 1. I'm subtracting them. You can do, for example, 2x minus 3x minus 2x equals 1x, which equals just x. Where do the numbers come from? This number is your percentage. This number is your original price, which is your unknown. Again, that 1 is implied to be there. And this number here is your new price. This number here, which I kind of scratched out, this number here is not the same as this number here. This number here is actually 50% minus your original, well, your original price minus 50% is your original price minus 50%. I don't know where to put the numbers. That was just me reading it. You will get plenty of practice with that next year. I did this one kind of algebraically. I might have taken a few steps that you don't know much about, like combining like terms here. I can see you might not. I don't know if we went over that or not. I'm sorry, everything is like blending in with all my classes right now. The other way to do this is to plug into percent over 100 equals part over whole. You can solve this way as well, right? Percent is 50, so that's 50% over 100. Your part, just pay attention, this is the sales price. This is not the whole price of the object. This is the sales price. So that would be 320 over your whole, which you don't know. And you can solve this way, and x here will equal 640 as well. So that's another way of doing it. Oh, my original price equals x, because I named it x, and 50% is equal to 0.5. So if I have x and I take half of x away, I'm left with the other half of x. If that makes more sense, explaining it that way. Oh, we're going to do a bunch, and actually, one is the only problem like this. I just wanted you to sit there and reason through things. I didn't expect you to do it this way. I thought you would look at it and be like, oh, this is half, so this was half the original price, so the original price must be double than this. And that's the other way to do it. Hey, if 50% equals 320, then 100% is times 2, times 2. That's how I expected you to do it. I wanted you to just reason through things. This isn't the main thing on what we're doing. I just thought those were just me explaining it different ways because I thought you didn't understand this way. Is the sale price on sale or what you take off the original price? The sales price is what you would pay. This number here is what you pay if it was 50% off. And it is, because that's what it's saying. So that's how much you're actually paying. Because it's 50% off, this is also going to say how much you're saving, though, because that's just how 50% works. And yeah, it is way easier this way. But let's move off this problem. This problem's giving me issues right now. Let's look at markup. In fact, yeah, markup. Markup is going to be, like I said before, when you go to a store to buy a good, like Giant Eagle or something, Giant Eagle didn't make well, some of the stuff in Giant Eagle is brand named. But let's say you go to Giant Eagle to buy an apple. Giant Eagle didn't grow that apple. It cost Giant Eagle money to buy that apple. Then they took how much they paid for that apple, increased the price of it to sell to you so they would make a profit off of it. And that's what we call a markup. How much did they actually increase that price? I guess I do have that definition. Yeah, so in the slideshow, if you're looking at the slideshow, it says to make a profit, stores charge more for the product than they paid for it, and the amount they increased is called your markup. Yeah, we'll do it. We'll do some other examples first too. So the markup is going to be equal to, so just to keep this in mind, just algebraically speaking, your markup is going to be equal to the store's cost, how much it costs the well, I guess I put it the other way, is going to be equal to the percent markup times the store's cost. So this is what we're looking at. We mark it up a percent, we multiply it how much we cost by, and that gives us our markup. What's important is markup was what Eli is actually just saying right there. Markup does not equal profit. Due to business-related issues. If there were no other expenses, then yeah, that would be true, I guess. Markup would equal the profit that they make off of it. But markup doesn't really equal your profit because you have to pay employees, you have to pay advertising, you have to pay all this other stuff that's going to eat into this here. But if you ignored all of that stuff, then markup does equal profit. You just have to ignore all your other overhead. So it's not really true, it's just the price that it increases. I think it'll be easier once we do an example. So I'm going to do the first example from the notes here. I'll walk you through this. This is probably going to be easier than what I just showed you doing the other stuff. So this is the problem from the notes. Okay, just to give you some context on what's going on. So it's saying that a computer store pays $6 for a computer mouse. So that's the store's cost right there, right? And the percent markup is 75%. That's this percent that we're going to multiply by. And we want to find the mouse's selling price. So this isn't even asking for markup. It's asking for selling price. And I also want you to know that markup doesn't equal selling price either. It's more closely related to profit than it is to selling price, actually, probably. So also what we're going to do is we're going to multiply this out. So what we're going to do is we're going to take this $6, which is the store's cost. So we're going to take $6, and we're going to multiply it by the percent markup. But again, we don't use percentages. So the first thing we're going to do is we're going to turn that into a decimal, which is 0.75. So turn into a decimal and use the decimal. We're going to multiply that by 0.75. And this is going to equal our markup. It's not going to be our selling price. And again, due to the fact that there are other issues that go into play to make a profit, it's not really going to equal your profit either. But here, we can solve this. We can do 6 times 0.75. So here your markup is going to equal $4.50 because it's money. So we're going to take it to that decimal point. It is going to be money. We're multiplying money times a percent, which doesn't have any units, and that's going to equal money. So here our markup is $4.50, not our selling price. And I want to make that clear. The markup is $4.50. The selling price is going to be equal to whatever the store paid for it, which is the $6, plus however much they're marking it up for, $4.50. So here your selling price is going to be $10.50. So the store buys it for this amount. For $6 is what the store buys it for. 75% is how much is what percentage they're going to mark up. That 75% of the $6 is going to be your $4.50. So this is how much the markup is. And then adding that $4.50 onto their original cost of $6, they're going to sell it for $10.50. So if you threw out all other expenses, like, hey, I don't have to pay for the store, I don't have to pay for the people that work at the store, I don't have to pay for any of the cash register or anything like that, and also taxes, you got to take off taxes and stuff like that, your profit would be the $4.50. But again, that's not realistic. You're not going to make $4.50 off of this. You have other things you got to pay for besides just the mouse itself to get the profit. So that's one example. What's the next thing on the slideshow here? Just walks you through it. So the other one that I might throw it up there. Yes, Eli. It's what the store pays times the percent markup. Yeah, we'll do number 2. There's really no difference between these. I don't want to save that. Oh, this is a discount one. I didn't want to get into discount yet. Let me find another markup one first. Number 3 is markup. We'll do that one in a second. And that's still discount. Let me find a markup one on here. Yeah, I'll start doing ones off the homework then. Get it easy. Boy, did I give you all discount ones? I gave you all discount ones on here. I wasn't thinking. All right, we'll move into discount. We'll move into discount ones. Markup's easier. Oh, these are all discount. All right, we'll look at number 2. Number 2 is discount. So be aware that discount is different. Discount we're taking off, markup we're adding on. So discount, well, let's say, markup, your price increases. Discount, your price decreases. So this is the difference. They are the same thing in every other sense, really, but keep in mind that discount, the price is going to decrease. And one way to do that is to adjust your percent right away. I will show you a couple ways to do discount, and discount is probably more for everyday life anyways. So one way to do that is to adjust your percent right away. So here Fred buys a video game disc for $4 and there's a discount of 20%. What is the sales price? So one way to look at this is you are going to be taking 20% of $4. So I want to know what is 20% of $4. Right? Once I figure that out, I just subtract that from my $4, and that will give you your sales price. What is 20% of $4? Right? I have a cost of $4. It's 20% off. So I'm going to take, if you want to relate it to what I did at the beginning, if you followed that, you're going to take your $4 and you're going to subtract 20% of $4, or 20% times 4, and that's going to equal your discount. Is it? No, that's going to equal your sales price. And that'll equal your sales price. This here will equal your discount. And then you take your discount and subtract it from your original price. You could do it that way, and that way is probably an easy way to do it, just by reasoning through things, right? So 20% of 4, and again, you don't use the percentage, so I can rewrite this as 4 minus, and we don't use the percentage, so that's going to be 0.2 times 4. Then 0.2 times 4 gives you just remember your order of operations gives you that 0.8, and you have 4 minus 0.8. Which equals $3.20. So 20% off. 20% will be 80 cents. And then subtract it. This is one way to do it. The other way to do it is to actually look at your percent and play with your percent first, if you're going for sales price. Because if you recall, I really don't care how much money I'm saving. Like this 80 cents, I really didn't care to figure out. But I can get my percent to be that is if you take the fact that it costs $4 and you're going to subtract 100% of that minus 20% of that, which is a little confusing the way I wrote that because I put the $4 there. But what I'm going to do is I'm actually going to subtract 20 from 100. So if 100% of the object equals $4, right, I save 20%, and that means I am paying 80%. So this would be total. This would be saves. This would be how much you're paying, right? If I'm saving 20%, then I'm paying 80%. So what's 80% of the whole cost? It would be how much I'm paying of it. So then you just do 80% of 4, which jumps you right to this step here. So 80% of $4. And again, if you want to rewrite things like this, that's fine. Then you can plug it into percent over 100 equals is over of, if you really wanted to. Or you can just remember that of here means multiply. And in that case, we don't deal with the percent. That'll be 0.8 times 4, which gives you that $3.20 as well. So that's just another way of saying it. He didn't buy it for $4. Maybe this is just worded weird. Fred buys a video game disc for $4. There's a discount 20%. What was the sales price? Yeah, I worded that weird. That makes no sense. The sales price would be $4 because that's what he bought it for. Originally priced for $4. There's a discount of 20. What was the sales price? I might have. Yeah, I probably just worded these wrong. I had to come up with these problems, so sorry about that. We can do the next one too. Let's find one that I worded right. Number 4 looks like a good one. This is number 4. A football is selling for 30% off the original price. The original price was $60. What is the sales price? So a football costs $60. Costs $60, and you are saving 35%. So the first way you can do it is if you're saving saving 35%, then you are paying 100% minus 35%, which gives you, I already know that answer, I don't know why I'm using a calculator, 65%. So you're paying 65%. That's one way to look at that. And then you just want to find out what 65% of 60 is. And that's just multiplying 60 times 0.65. And this will equal your sales price. Yeah, Logan, we're going to spend the rest of the week doing problems like this, though. So I know it gets confusing at first, but once you kind of catch on, it's going to work out. Try your best on this page. I don't know if anything is unlocking for tomorrow because I'm not going to live stream tomorrow. I don't remember what I put on there. Tomorrow is the 22nd. Yeah, I just said continue working on the discount problems from today. But I don't have any I'm not giving you anything new tomorrow. It's all right. This is a bit of a confusing topic because it does take some reasoning skills, and it's a little tough to do it over the internet too. But I do plan on spending more time on it. So be aware of that. This is me just rewording things. I mean, I could give you formulas and you can plug in the formulas for it too. I just don't want to do that just yet. I want you to try to do some reasoning for it. And the fact that I kind of worded some of these problems wrong isn't helping either. But this will give you the answer, right? So it's you're saving money versus things. Just try to keep straight on what each number means. It costs $60 here. You're saving 35%. So you're going to be paying 65% because 100% minus 35% equals 65. You pay the remaining percentage. So you're paying 65% here. So you can solve it this way. The other way to solve it is to do I guess I could give you a little template. I can make one up right now. So you're going to take your original price and you're going to subtract it from 1 minus your percentage as a decimal. That's going to equal your sales price. That's going to be true for all of these if you want to rationalize things. So your original price here was $60. You're going to subtract that from 1 minus your percentage, but again, use your percentage as a decimal. So this is actually going to be 0.65, which is going to be 1 minus 0.35 equals your sales price. So again, that's going to be 60. Am I subtracting that? No, I'm multiplying this. Should be multiplication there. Yeah, so 60 times, and this here is going to be your 0.65 equals your sales price, which is 60 times 0.65. It's $39. That's still $39 as well. So I can clear all this up and I'll just give it to you generically. So for discount, you're going to take your original price minus your discount, and that's going to equal your cost. That's how much you're paying it. So here you have your original price, but to find your discount, you're going to do I don't want to do that. This is going to be weird because it's going to combine it with what I did before, and that's not going to make sense to you. Are you getting it, the correct answers? I don't know, did you get, was it $39 the other way, Abby? Okay, first thing you want to do is, I don't know, there's many ways to do these. So you're taking your original price you're multiplying it by 100% minus your discount percent, which would be whatever percent you're given here. And that will equal your discount. No, that'll equal your sales price. Right. Original price minus your times your percentage equals your discount. That will equal your discount. So your original price would be 60 times your percentage 0.35. That means $21. So this is your discount. This is saving $21. That's not what you're paying, that's what you're saving. So to get what you're paying, you then take your original price. So sales price is going to be your original price minus your discount. So that's going to be 60 minus your 21, which is going to give you $39. 60 minus 21 gives you $39 for your sales price. So you could do it that way. Or you could honestly skip this step and just do the percentage, change the percentage in your head. Because you know if you're saving 35%, then you're paying the remainder of it. So 100% minus 35 gives you 65%. So you're paying 65%. So with that, you can switch out this with 65 and get this answer here. So you could do 60 times 0.65, which would give you your $39. But just keep track of what you're actually solving for. These are solving for sales price. This is solving for how much you actually save. This here is your discount, not your sales price. What I'm going to do is I'm actually going to end it. I'm going to say try them, see what you can come up with. On Thursday, we're going to do more of the same thing. So if you get completely lost, don't worry about it. We'll work on it with you on Thursday and go from there. So try your best, give it a shot, take a break from it today and go on. Does original price minus discount equal sales price? Yeah. Sorry, this equals sale price. Right. And I can probably look up the formula for it. There's a formula. I just want you to understand where things are coming from. The notes might have explained it better too. I kind of stopped following them after a while. I don't remember exactly what I all read here. The hardest part about these is the fact that you got a whole bunch of numbers going around and they all mean different things, and you got to keep track of what each number means as well as its value. Like you got to remember 60 is your original price, 35 is what you're saving, therefore 65 is what you're paying. 35% of 60 is $21, so you're saving 35%, you're saving 21%. 65% of 60 is $39, so you're paying 65%, you're paying $39. It's just a lot of information floating around. So I will do more of them for you Thursday. Give them a shot. That's what I'm asking for today. If you haven't finished the review, work on that some too. But don't worry, we're not going to move off of this topic until we start understanding it better. So with that, I am going to end it because we're past our 20 minutes. I want you to try to get an answer, Catherine. That's all I want you to do. Try to get an answer. I don't care if it's the right answer right now. Just try to get an answer. Look at it and see if you can get an answer. I will look for maybe a video or something I can post in the classroom that explains it better. But again, I'm going to be out. I actually have to go into school tomorrow, so I won't be live streaming. And then on Thursday we'll look at it again, anyways. If you're still completely lost, but hang in there. Give it a shot. That's all I'm asking is to try. I know it's confusing, and I was planning on spending the rest of the week doing this anyways. With that, I am going to end it. I will talk to you Thursday. If you are really lost, you can email me. I might be able to give you something.